Canny College is dedicated to empowering individuals to excel in their auto body and collision technician trade through top-notch preparation courses for the Auto Body and Collision Technician Licensing Exam. Our online course is comprehensive and designed to equip you with the skills, knowledge, and confidence needed to pass the demanding Red Seal Trade License Exam and earn your Auto Body and Collision Technician Certificate of Qualification. We are your trusted pathway to success in the Canadian Red Seal Trades License Exams, a crucial milestone on your journey to a rewarding career in the skilled trades industry. Aspiring professionals seeking a Canadian Red Seal trade license can rely on our institution's expertise. Canny College offers comprehensive online exam preparation courses for various skilled trades. It uses an innovative learning approach and a commitment to excellence to equip students with the essential skills and expertise required to succeed in their chosen trades. Visit our website at www.cannycollege.com for more details. Please note that the practice questions provided here demonstrate the structure and phrasing of Red Seal examination questions. They are for study purposes only and do not result in certification or reflect actual performance on the examination. Question 1. When is the foam tape removed from a spot repair after applying a clear coat? A. After 24 hours of cure time. B. After polishing the panel. C. Immediately after the bake cycle. D. Immediately after the flash of the last coat. The correct answer is D. Immediately after the flash of the last coat. The correct procedure for removing the foam tape from a spot repair after applying a clear coat is immediately following the flash of the last coat. Here are the reasons why this timing is crucial. 1. Immediate removal. Removing the foam tape immediately after the flash of the last clear coat ensures that the tape is removed while the paint is still in a tacky state. This helps prevent the tape from sticking to the clear coat film as it continues to cure. 2. Clean edge. By removing the foam tape promptly, you can achieve a clean and sharp edge on the repaired area. If the tape is left on for too long, it may become more challenging to remove, potentially leading to imperfections or uneven edges in the clear coat. 3. Minimize damage. Removing the foam tape at the correct time minimizes the risk of the tape pulling away fresh paint layers or causing damage to the repaired area. This is essential for achieving a smooth and seamless blend between the old and new paint. 4. Final finishing. Once the foam tape is removed, the repaired area can be further polished and finished, leading to a smooth and glossy surface that seamlessly integrates with the surrounding paint. In summary, removing the foam tape immediately after the flash of the last clear coat in a spot repair allows for a clean edge, minimizes the risk of damage, and ensures a professional finish for the repair work. Question 2. How is minor orange peel eliminated on a clear coat refinished panel? A. By refinishing. B. By wet sanding and polishing. C. By polishing the panel only. D. By wet sanding the panel only. The correct answer is B. By wet sanding and polishing. Here are the reasons why. 1. Wet sanding, minor orange peel in a clear coat. Finish can be effectively eliminated by wet sanding the panel using fine grit sandpaper. Wet sanding involves using water as a lubricant to smooth out the uneven surface and level the orange peel texture. 2. Smoothing the surface. Wet sanding allows for gentle abrasion of the clear coat, which helps remove the textured surface of the orange peel while maintaining a smooth finish. This process gradually reduces the imperfections in the clear coat. 3. Polishing. After wet sanding, the panel should be polished to restore the gloss and shine of the clear coat. Polishing the panel helps remove any sanding marks, fine scratches, and haze left behind from the wet sanding process, resulting in a smooth and well-blended finish. 4. Professional results. By combining wet sanding and polishing techniques, minor orange peels can be effectively corrected, resulting in a high-quality finish that matches the overall appearance of the vehicle. These steps ensure that the refinished panel looks uniform and professional. In summary, wet sanding and polishing is the recommended method for eliminating minor orange peel on a clear coat refinished panel, as it smooths out imperfections and restores the gloss and shine of the finish. Question 3. Where is a quarter panel sectioned on a four-door sedan? A. Through the B pillar. B. Through the C pillar. C. Along the wheel housing. D. Vertically through the center. The correct answer is B. Through the C pillar. Here are the reasons why a quarter panel on a four-door sedan may be sectioned through the C pillar. 1. Structural considerations. The The C-pillar is a structural component of a vehicle's body that connects the roof to the rear quarter panel. Sectioning through the C-pillar allows for focused repair or replacement of the damaged section within the context of the vehicle's structure. 2. Access and integration. Sectioning through the C-pillar provides access to areas where the quarter panel is joined to the vehicle's overall body structure. This allows for a more seamless repair or replacement process that integrates well with the existing components. 3. Alignment and fit. Segmenting the quarter panel through the C-pillar can help ensure proper alignment and fit of the new panel to the vehicle. This approach considers the natural lines and contours of the vehicle, leading to a repair that blends harmoniously with the rest of the body. 4. Maintenance of design. By sectioning through the C-pillar, the design and aesthetics of the vehicle can be maintained, with the repair work seamlessly integrated into the overall appearance of the four-door sedan. In summary, sectioning through the C-pillar for a quarter panel repair on a four-door sedan can provide structural integrity, access, alignment, and aesthetic considerations for a successful repair or replacement process. Question 4. Which gases are used when MIG welding mild steel? A. Argon and CO2. B. Argon and NO2. C. Acetylene and CO2. D. Argon and O2. The correct answer is A. Argon and CO2. Here are the reasons why. 1. Argon. Argon is often used as the primary shielding gas in MIG welding for mild steel. It helps to protect the weld pool from atmospheric contamination by displacing the oxygen and other gases that could cause oxidation and compromise the quality of the weld. 2. CO2, carbon dioxide. CO2 is another shielding gas commonly used in MIG welding of mild steel. It is particularly effective for deep penetration welding and is often used in combination with argon to enhance the welding process and achieve good weld quality. 3. Welding mild steel. Mild steel is a commonly welded material, and the combination of argon and CO2 gases provides an ideal shielding atmosphere for achieving strong, clean welds on mild steel components. 4. Shielding effectiveness. The combination of argon and CO2 gases in MIG welding provides an effective shielding environment that helps prevent the formation of defects, such as porosity and excessive oxidation, resulting in high-quality welds on mild steel. In summary, argon and CO2 are a common and effective gas combination used in MIG welding of mild steel, providing the necessary shielding and protection to produce strong and clean weld joints. Question 5. Which type of weld is used on a thermoplastic bumper cover? A. Solvent weld. B. Friction weld. C. Fusion weld. D. Adhesive weld. The correct answer is C. Fusion weld. Here are the reasons why. 1. Fusion weld. Fusion welding is a technique commonly used for joining thermoplastic materials by melting and fusing the parts. In the case of thermoplastic bumper covers, fusion welding involves heating the edges of the bumper cover materials until they soften and then pressing them together to create a seamless bond. 2. Thermoforming capabilities. Thermoplastic materials have the characteristic of softening and becoming malleable when exposed to heat. Fusion welding leverages this property by heating the bumper cover material to a temperature where it can bond with itself when pressed together, creating a strong weld. 3. Seamlessness. Fusion welding on thermoplastic bumper covers results in a seamless bond between the parts, maintaining the structural integrity and aesthetics of the bumper cover. The melted edges blend when fused, creating a smooth and continuous surface. 4. Durability. Fusion welding forms a strong and durable bond between thermoplastic materials, ensuring that the joined parts maintain their integrity and withstand the rigors of automotive use, including impacts and environmental factors. Question 6. After a cooling system repair, antifreeze is noticed on the ground. A pressure test finds no leaks. Which component is faulty? A. Heater core. B. Water pump seal. C. Heater hoses. E. Radiator cap. The correct answer is D. Radiator cap. Here are the reasons why. 1. Radiator cap function. The radiator cap plays a crucial role in maintaining the proper pressure in the cooling system. A faulty radiator cap can lead to a loss of pressure, causing coolant to escape and spill onto the ground, even if there are no visible leaks elsewhere. 2. Pressure regulation. The radiator cap is designed to regulate the pressure within the cooling system. If the cap fails to seal properly or maintain the correct pressure, it can result in coolant leakage and overflow. 3. Coolant overflow. An improperly functioning radiator cap can cause excess pressure buildup in the cooling system, leading to coolant overflow, which may be observed as spilled antifreeze on the ground near the vehicle. 4. Hidden fault. The radiator cap may have a small or concealed defect that is not evident during a visual inspection. A pressure test may not always reveal issues with the cap if it fails intermittently or under specific conditions. Therefore, if antifreeze is present on the ground after a cooling system repair, and no other leaks are found during a pressure test, the radiator cap should be examined for potential faults, as it may be the component causing the coolant to escape. Question 7. How is uneven sanding prevented when repairing a large dent? A. By using a long sanding block with a crosshatch pattern. B. By using a short sanding block with long even strokes. C. By using a long sanding block with long even strokes. D. By using a short sanding block with a crosshatch pattern. The correct answer is A. By using a long sanding block with a crosshatch pattern. Here are the reasons why a long sanding block with a crosshatch pattern helps prevent uneven sanding when repairing a large dent. 1. Crosshatch pattern. Sanding in a crosshatch pattern involves sanding at multiple angles, typically perpendicular or diagonal, to the length of the panel. This approach helps to evenly distribute the sanding action across the surface and prevents uneven removal of material. 2. Long sanding block. A long sanding block provides stability and a flat surface area for sanding large sections of a panel. The length of the block helps ensure that the sanding action remains consistent and even, prevents waves or uneven spots in the repaired area. 3. Smooth transition. By using a long sanding block with a crosshatch pattern, technicians can feather the edges of the repair seamlessly into the surrounding area. This technique helps blend the repaired section with the rest of the panel and avoids noticeable ridges or differences in the surface. 4. Control and precision. The combination of a long sanding block and a crosshatch pattern allows for greater control and precision during the sanding process. This helps maintain a consistent level of material removal and ensures a smooth, uniform surface. By employing a long sanding block with a crosshatch pattern, automotive professionals can effectively address large dents and achieve a smooth, even surface without creating waves or uneven spots in the repaired area. Question 8. What is the final step before masking a vehicle for primer surfacer application? A. Wash the vehicle with soap and water. B. Blow and wipe the vehicle clean. C. Wipe the surface with a tack cloth. D. Wash the surface with thinner. The correct answer is B. Blow and wipe the vehicle clean. Here are the reasons why blowing and wiping the vehicle clean is the final step before masking for primer surfacer application. 1. Removal of debris. Blowing compressed air over the vehicle's surface helps to remove any loose dust, dirt, or debris that may have accumulated, ensuring a clean surface for the primer surfacer application. 2. Even distribution. Using compressed air allows for an even distribution of air over the vehicle, reaching areas that may be difficult to access by hand. This helps in dislodging particles that could potentially affect the quality of the primer surfacer finish. 3. Precision cleaning. Wiping the surface clean after blowing ensures any remaining dust or particles are removed, preparing the surface for masking and primer surfacer application. This step provides a thorough and detailed cleaning process. 4. Contaminant removal. Dust and debris left on the surface can cause imperfections in the primer surfacer application, affecting the adhesion and overall finish quality. Blowing and wiping the vehicle clean helps eliminate contaminants and ensures a smooth surface for the next step in the refinishing process. In summary, blowing and wiping the vehicle clean is essential before masking for primer surfacer application, as it helps remove debris and contaminants that could impact the quality of the finish and promotes a smooth and professional result. Question 9. Which PPE is required when mixing self-etch primers in a well-ventilated area? A. Rubber gloves and safety glasses. B. Nitrile gloves and particle respirator. C. Nitrile gloves, coveralls, charcoal respirator, and goggles. D. Latex gloves, coveralls, charcoal respirator, and face shield. The correct answer is C. Nitrile gloves, coveralls, charcoal respirator, and goggles. Here are the reasons why. 1. Nitrile gloves. Nitrile gloves are recommended for chemical resistance when handling self-etch primers to protect the skin from potential irritation or contact with the chemicals in the primer. 2. Coveralls. Coveralls help protect clothing from primer splashes or spills and minimize skin exposure when working with self-etch primers. 3. Charcoal respirator. A charcoal respirator or mask is essential for respiratory protection when mixing self-etch primers to prevent inhalation of fumes, vapors, or airborne particles. 4. Goggles. Goggles provide eye protection from splashes or accidental contact with self-etch primers, ensuring the safety of the eyes during the mixing process. Wearing the appropriate PPE, as outlined in option C, can help ensure the safety and protection of the individual when working with potentially hazardous chemicals, such as self-etch primers. Question 10. How are natural oils on the skin prevented from affecting the quality of the paint job? A. By wearing gloves while sanding or puttying. B. By cleaning and priming only a small area at a time. C. By not touching surfaces that have been prepared for paint. D. By using power equipment rather than hand methods for all finish sanding. The correct answer is C. By not touching surfaces that have been prepared for paint. When working on surfaces that have been prepared for painting, it is essential to avoid touching them with bare hands to prevent natural oils on the skin from affecting the quality of the paint job. Here are the reasons why. 1. Contamination. Prevention. Natural oils present on the skin can transfer to the prepared surface upon contact, creating a barrier that interferes with the adhesion of the paint. This can lead to issues such as poor paint adhesion, fish eyes, or bubbling. 2. Surface cleanliness. Keeping the prepared surface clean and free from contaminants is crucial for achieving a smooth and durable paint finish. Touching the surface with bare hands introduces potential contaminants that may compromise the integrity of the paint job. 3. Adhesion quality. Avoiding contact with prepared surfaces helps ensure that the paint adheres well to the surface, resulting in a professional-looking finish that is free from imperfections caused by skin oils. 4. Consistent finish. Consistency in the paint job is vital for achieving uniform color and texture. By refraining from touching the prepared surfaces, you can maintain a consistent application of paint without interference from skin oils. In summary, by preventing skin oils from coming into contact with surfaces that have been prepared for painting, you help maintain the cleanliness and integrity of the surface, leading to a high-quality and durable paint job.